All right, I want to take a look at rate of change, which is in lesson 9 for college algebra. But before we actually talk about average rate of change, I want to go back and kind of review with you a concept that you learned back in lesson 6, which was the idea of a slope. Slope is a measurement of the steepness or the tilt, specifically of a line. And you're probably familiar with slope, and it looks at the relationship between the vertical change and the horizontal change. Let's see if I can kind of sketch you a rough picture here of what goes on. So you have our good old everyday coordinate grid system. The horizontal axis is X, the vertical axis is Y, and you would have a line, and we would want to consider the relationship as we move from one point to a second point. So if we have the first point, x1, y1, and a second point, x2, y2, the little subscripts simply indicate this is the first point, this is the second point, and we want to think about what would happen as we move from one point to the other. How much would we have to move horizontally? Okay, so you would have your horizontal change, and horizontally we're parallel to the x-axis, so this would be x2 minus x1, okay? And then we also want to consider how much we would change vertically. It's like you're climbing the hill. So how steep is the hill? So this would be your vertical change. We're parallel to the y-axis, so it would be y2 minus y1. If you're curious, just so you'll know, this point in the corner, kind of where you had to turn the corner here, would be x2, y1. Okay, x2, y1. Okay, so again, hopefully that's one you're familiar with. A lot of you may remember rise over run, where it's the vertical change compared to the horizontal change, and again, you have the formula. So once you know the formula for slope, you can actually find it simply by plugging and chugging. So for example, in lesson 6, you had a question similar to this. Find the slope of the line that passes through the given points, -3, 2, and 4, -7. So one of the things I like to do before I start is label my points. So I would label x1, y1. I label the first one the first point and the second one the second point. It really doesn't matter, okay, but I like to label them that way. And then I also like to go ahead and write my formula on my paper right where I'm working it so I don't get mixed up. So the slope formula is y2 minus y1 over x2 minus x1. And then it basically becomes a plug and chug where I'm going to substitute in the numbers that I'm given and do the calculations. So I would have -7 minus 2 and 4 minus -3. -7 minus 2 is -9. Then I would have 4 minus and a minus make a plus. So 4 plus 3 would be 7. So my slope is -9 over 7. Okay, so that's the concept that you learned in lesson 6. In lesson 9, they want us to talk about rate of change. And it's the same idea. We're looking at how one value changes with respect to another. Specifically with rate of change, we look at how the output or the y value changes with respect to the input or the x value. And you probably deal with this somewhat on a daily basis. You just don't think about it. It might be that you earn $7.25 per hour. So the rate of change is $7.25. Miss Ralston travels 80 miles per hour to get to work. If you look at, they're looking at speed, 80 miles per hour. The world population increases by 82 million people per year. 55.3 million people die each year. Miss Ralston's vehicle gets 24 miles per gallon of gasoline. Okay, typically when you're thinking about rate of change, you're thinking about things like the amount per hour or the miles per hour or people per year. You got that per idea. And with average rate of change, it's similar to slope, but instead of applying it to lines, we apply it more to things like a parabola. We can apply it to kind of any kind of loop-to-loop curve. We can apply that, apply average rate of change. And it's the same idea though, because we're looking at the change in the Y or the output in comparison to the change to the input. Now the notation changes a little bit, which is sometimes a little bothersome to students. You see this little triangle, okay? And that triangle is the Greek letter delta. And in mathematics, not just algebra, but across the board in mathematics and calculus and all the others, it means change in. So delta y means change in the y, and then delta x would be the change in x. And if you'll notice, the formula itself pretty much looks like the slope formula. So average rate of change is a similar concept to slope, but it's applied to curves or non-linear functions. So here's an example where you're asked to find the rate of change using a graph. It says find the average rate of change on the interval -1, 2. Now what you have to remember is that these values in this interval are your x value. So this would be like your beginning value is x1, your ending value is x2, and you're going to use the graph to find the corresponding y. So I'm going to look at the graph and I want to think about what happens or what value do I have when x is -1. So if I go over here and look at my number line, here's -1, and I'm going to read up till I run into the graph, and it looks like the ordered pair at that point would be -1, +4. So my output for -1, which would be my f of x sub 1 or y sub 1, is 4. Then I go and I look and I need to find the value for my second value or my ending value, which is 2. So again, I'm going to come over here to my number line. On the horizontal, I'm going to find where x is 2. Then I'm going to read up the graph. So I have 1, 2. Okay, so the f of x sub 2 or y sub 2 is 2. Now, again, what you're really finding here, guys, is you're looking for the average rate of change has to do with this line that connects those 2 points. So my rate of change, delta y, delta x, is f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. And I've found those points using my graph, and so I'm going to plug in. So I would have 4 minus 2 over 2 minus a minus 1. Oops, sorry, I got it backwards. Got to put them in the right order. Let's see, let me get it right here, guys. Okay, my f sub 2 is 2. I have 2 minus 4, and then I have 2 minus a -1. So 2 minus 4 is a -2. 2 minus a -1 is 2 plus 1, or 3. So the slope, or the average rate of change between -1, 4 and +1, 2 is -2/3. So the average rate of change on that interval is -2/3. And hopefully you can see that visually. The negative implies it's going down, and it does appear to do so. All right, I'm just going to randomly kind of draw a curve here, so you'll have one that's just kind of really different. Okay, so there we go. This wants you to estimate the rate of change from x equals 1 to x equals 4. Okay, so when x equals 1, here's 1, and that would correspond to the ordered pair 1, 7. Then the other value we're interested in is 4. And I would have 4, 8. Okay, so basically you use your graph to identify your two ordered pairs, and then the rate of change is delta y, delta x. You subtract f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. Now, I didn't, but it may be helpful if I label these points. Let's label these x1, y1, and x2, y2. I'm going to do my substitution. So I'd have 8 minus 7 over 4 minus 1. So I'd have 1 over 3. And again, we're trying to find this line here that connects. This, basically, the idea behind it is finding the slope, or the rate of change, from one point to the other point. So you can do it graphically. You just read the information from the graph. You can also do it using a table. Okay, so with a table, it says find the average rate of change in annual sales between 2001 and 2004. So they want you to focus on what happens in 2001 and what happens in 2004. Okay, so you're going to focus on these 2 points here. And again, this would be like your x1, y1, x2, y2. We're going to figure the average rate of change. That verbiage, that phrase lets you know, oh, I need that formula, which is delta y, delta x. You have y2 minus y1 over x2 minus x1. So I would have 249 minus 243 divided by 2004 minus 2001. So that gives me 6 over 3, or 2 to 1. So basically, between 2001 and 2004, the annual sales increased by $2 million per year. Okay, that's how you interpret it if you needed to interpret it. This idea of the rate of change being 2, we're basically saying that between 2001 and 2004, the annual sales increased. And I know it's an increase because that rate of change is positive. It increased by $2 million per year. You can also do it if you have an equation. Now that requires a little bit more steps because you have to actually do some calculations and some work. So it really becomes almost a 3-step process. So this example says find the average rate of change of g of x equals x squared plus 3x plus 1 on the interval 2 to 4. So step 1 is you need to find g at 2. What happens at that beginning point of the interval, which requires you to substitute 2 into the function itself. So I'm going to do that. So I would do 2 squared plus 3 times 2 plus 1. That's 4 plus 6 plus 1, which equals 11. So g at 2 is 11. So I have the ordered pair 2, 11. Then I go back, and step 2 is to find g at 4. You need to find the corresponding value for the ending point. So we would have 4 squared plus 3 times 4 plus 1. That's 16 plus 12 plus 1, which equals 29. So you have the ordered pair 4, 29. Then finally, you go back and you have the two pieces that you need, or the two ordered pairs that you need. So step 3 is you find delta y, delta x, which is y2 minus y1. Okay, and it becomes a plug and chug. You have your two ordered pairs. You may want to label them x1, y1, x2, y2. So I have 29 minus 11 over 4 minus 2. I have 18 over 2, or 9. So the average rate of change of x squared plus 3x plus 1 on the interval 2 to 4 is 9 units. Okay, it's a 3-step process. It's not hard. It's a lot of plugging and chugging. If you're having trouble with the math, use your calculator. All right. The next one asks you to find the average rate of change from an interval of 4 to the letter A. So you can be asked to do this with an expression as opposed to a number, but it's the same concept. We start out, we have to find the value of the function at the beginning point, which in this case is a 4. So we would have 2 times 4 squared minus 9. That's 2 times 16 minus 9. 32 minus 9 is 23. So you would have the ordered pair 4, 23. We go back. Step 2 is you want to find the value of the function at the ending value, which in this case happens to be the letter A. So we would have 2a squared minus 9. So you have the ordered pair a, 2a squared minus 9. And then you put the two together to find delta y, delta x. So I have y2 minus y1 over x2 minus x1. And again, if I label these x1, y1, x2, y2, and I do the substitution, I would have 2a squared minus 9 minus 23 over a minus 4. So if I simplify this, minus 9, because you have like terms here, you want to put them together. Okay? Minus 9 and minus 23 gives me 2a squared minus 32 over a minus 4. Now I realize some of you may think at that point that you're finished, But guys, you're not, because that is a fraction, and we know from earlier algebra days you want to simplify that fraction. So I noticed that first off I have a 2 in common in the numerator, which gives me a squared minus 16 over a minus 4. I then notice that I can factor a squared minus 16 as a difference of two squares. So we get a plus 4, a minus 4. I actually have the expression a minus 4 in the numerator and denominator. So it actually divides out, and I'm left with 2 times a plus 4. So this would actually be your average rate of change. Okay, you have to make sure if it's a fraction or a ratio with letters, numbers, or any combination that you simplify it. Okay, so there's some examples and hopefully a better explanation of average rate of change.